All right, guys, so today we're going to learn about special right triangles. This is a little bit of an offshoot of the Pythagorean theorem. Special right triangles, there's two of them. We have a 45, 45, 90 that we'll talk about today, and then the 30, 60, 90 that we talk about tomorrow. But these have special relationships, which means we can solve these fairly easily. So the first thing I'm going to do is I'm going to look at this square. All the angles are 90 degrees, and notice that the sides are all congruent. And the first thing I'm going to do, in number one, is draw a diagonal. So I'm going to come over here and start in the top right corner and sketch a diagonal that goes to the bottom left corner. So step one is complete. Number two, label the legs as X. So the legs are the sides that are touching the 90-degree angle, because remember, in the Pythagorean theorem, the side across from the right angle is our hypotenuse. So I'm going to say that this leg is X and this leg is X because they're congruent, so they're both the same thing. Now, number three, I'm going to find the hypotenuse. So I can take the two legs, square them and add them together, and they should equal c squared, which is the hypotenuse. So I'm going to say x squared for one of the legs plus the other x squared should equal the hypotenuse squared by using the Pythagorean theorem. Now I can take x squared and add them together, and I get 2x squared equals c squared. Now we would take the square root of both sides. Well, I can't take the square root of 2, so it's stuck inside, but I can take the square root of x squared, and I get x. And then I'm going to put that square root of 2 after it, and that should equal c, which is our expression for our hypotenuse in a 45, 45, 90, x square roots of 2. So anytime you're solving for a missing length in a 45, 45, 90 triangle, go ahead and label it just like that. The legs are both x, and the hypotenuse is your x square roots of 2. So what's going to happen is every time we have one of these, they're going to give us one side, and we're going to find the other two using those expressions. So the first one's pretty easy. It says find the lengths of the missing sides. Well, I'm going to go ahead and label it just like I did the last one. The hypotenuse is your x square roots of 2, and both your legs are the x. But they gave me one of the legs, so I know what x equals, and I can use that to plug in and find the other sides. Well, if x equals 5, that means that this bottom leg is also 5. So AB is 5 units. The next one is x square roots of 2. Well, I know that x is 5, so in this case I can just substitute it in, and you get 5 square roots of 2. So AC is 5 square roots of 2. Now I want to do this, and we really need to start practicing this simplifying our radicals. I'm going to do this like I knew both sides were 5 and didn't know about special rights. So I'd have 5 squared plus 5 squared equals c squared. That's 25 plus 25 equals c squared, which is 50 equals c squared. Now we would take the square root of both sides, and c would equal the square root of 50. But we need to simplify. So bring that 50 out to the side, and this is just practice for later. I need to break it down into its prime factors. Well, I can divide 50 by 2 and get 25. And 25 isn't divisible by 2 or 3, those two primes, but it is by 5, and I get 5 and 5. Well, remember, we're looking for pairs when we simplify radicals. I have a pair of 5s, so the 5 would come out, but the 2 has to stay in because it's by itself, which is exactly what we got over here. So using special right triangles really is a time saver. Let's simplify. Man, I keep hitting that. I'm on the next page and something a little bit more complicated. Over here, this time, they gave us the hypotenuse. Sorry about that, guys. I need to find the hypotenuse, or I have the hypotenuse, and that's my x square roots of 2 side. So my goal is going to be find x, so I can find the legs. So I know that x square roots of 2 equals 4, and if I could solve for x, then I can plug that in and have both of my legs. But this creates a little bit of a problem for us. If I divide both sides by the square root of 2, the square roots of 2 cancel, and I get that x is 4 square roots of 2. So I'm going to write that down here. Unfortunately, guys, I'm going to write a little blurb up here. A radical can't be in the denominator. So we have to fix it. And I'm going to warn you, if you don't fix it on your homework, I'm going to take off a lot of points. Now, this is called multiplying by a clever form of 1. When we multiply things by 1, it doesn't change anything. X times 1 is X. 10 times 1 is 10. So I can multiply this by something that's equivalent to 1 and will actually cancel out that radical in the denominator. So I'm going to multiply this by the square root of 2 over the square root of 2. So whenever you fix these, you take that radical in the denominator, turn it into a fraction of itself over itself, and that's really just multiplying the whole thing by 1. So 4 times the square root of 2 is just 4 square roots of 2. But on the bottom, that's the square root of 2 times the square root of 2. And we've actually seen this before. That's the same as the square root of 2 squared. Well, the squared cancels out the radical and just leaves what's inside. So guys, and this is something you really need to hammer home because it's going to happen in Algebra 2. When you multiply a radical by itself, the radical goes away. So for example, the square root of 5 times the square root of 5 is 5. The square root of 17 times the square root of 17 is 17. So remember that as you're working through here, because now I have a fraction that does not have a radical in the denominator. However, I can't. When you're simplifying, though, you don't simplify what's inside of a radical. It's trapped. You simplify what's on the outside. So basically, I have 4 divided by 2 gives me 2, and then I have the square root of 2 hanging around after it. That is my x. So I know that this is 2 square roots of 2, and this is also 2 square roots of 2. Now, this is probably the hardest part of the whole thing, so make sure you practice this and do it on your homework. Let's look at another one where something similar happens. So I've got my special right triangle. I know that my hypotenuse is the x square roots of 2 side, and the 2 legs are both x. So I have x square roots of 2 equals 3 square roots of 15, and I'm basically going to follow the same process as I did last time. First, I divide by the square root of 2 to isolate x. So x equals 3 square roots of 15 over the square root of 2. Now I use my clever form of 1 to clear the radical from the denominator by multiplying by the square root of 2 over the square root of 2. I'm going to do the denominator first because remember the square root of 2 times square root of 2 is 2. The radicals disappear. But on the top I've got numbers outside and inside. You treat them separately. Really there's a 1 outside of this that's not given. So 3 times 1 would just be 3. But then when I multiply things that are inside the radical, I have to multiply them together. So 15 times 2 would be 30. So I have the square root of 30. Now, lucky for us, the square root of 30 cannot be simplified, so I'm left with my answer, 3 square roots of 30 over 2. So both x's are 3 square roots of 30 over 2. So those are AB and BC. And I want to show you, just in case, why 30 can't be simplified. If I take 30 out and I start to break it into its primes, 2 brings out 15, but then 15 isn't divisible by 2, but it is by 3, and it gives us 5. There are no pairs there to pull out, so therefore I cannot do anything else with the square root of 30, but you do need to check, so be careful. So get one more. They gave me x this time as one of the legs. I know the hypotenuse is x square roots of 2, and the other leg is x. So I already know CB is 2 square roots of 3. That was pretty easy. But now I need to replace that x in the x square roots of 2 with 2 square roots of 3. So I'm going to say 2 square roots of 3 times the square root of 2. So guys, all I did there, let me change colors, was took this 2 square roots of 3 and plugged it in for x. Now we've got this multiplying radicals business going on again. Well, I still have 2 times 1, so I get 2 on the outside, but it's the square root of 3 times 2, which is 6. Now 6 also cannot be simplified, so my AB answer is 2 square roots of 6. So just so you know, if I take 6 out, I can divide it by 2 and get 3, and they're both primes, and there's no matches. Now this can be a little bit complicated, guys, and it's going to happen again when we do a 30, 60, 90. So if there are any questions about this, we really need to cover them tomorrow before we jump into the next section. So if you have any questions, make sure and remember them for tomorrow, and good luck.